Welcome to ZKast, everybody. I'm Zeus Caravallo from ZK Research. I'm your host, and I'm back for another thought leadership ZKast. I'm joined by Shehzad Merchant, the CTO of Gigamon, and we just talked to Shehzad, but we're going to go a little deeper on a couple topics. So, Shehzad, why don't you say hi and tell us how you're doing?
Zeus, it's always good to be back with you over here, and I'm looking forward to this conversation.
Yeah, it's going to be a good conversation. We're going to talk about observability, specifically deep observability again. But before we get going, I do want to give a quick shout out to eWeek, my media partner. All Zcasts are done in conjunction with the eWeek eSpeaks series. Now, Shehzad, the last time we did one of these, and I'll make sure I include the link to this in the description, we talked specifically about deep observability. And I thought it was worth going deeper on the topic because observability is such a broad topic today. So real quick, just remind us, what is deep observability and how does it vary from this topic of observability that it seems everybody's talking about today?
Yeah, it's a good place to start today's conversation. And so as we discussed last time, and quickly to recap, observability refers to monitoring workloads in the cloud using MELT, metrics, event logs, traces. And primarily with the intention of monitoring cloud infrastructure for performance, bottlenecks, and cloud operations. Now, DevOps has mastered the use of observability to deal with large ephemeral workloads using data warehousing and querying techniques. But the thing about observability is that it takes an inside-out look at the workloads. In other words, the telemetry that is used for monitoring the workloads and the infrastructure comes from within the workloads and the infrastructure. For example, the logs that are generated from the endpoints or from the workloads, as an example, right? Deep observability, on the other hand, extends that paradigm by bringing an outside-in perspective. In other words, looking at network traffic, extracting network intelligence from that traffic to fill in the gaps so that operators can apply the DevOps approaches, but they can apply it to security now, where the traditional observability techniques fall short.
It's surprising to me, too, that MELT is still largely used as the gold standard for observability. If you think of, we started using the concept of MELT back when applications were kind of monolithic things that sat in a data center, right? And I think at the time that was actually a pretty big leap forward for observability. But you have to remember when in that era, if you had an application, it was deployed in a data center and you had all your infrastructure there. Today, we've kind of scattered everything all over the place. And so in order to have observability, you're right, we do need to use the network as a way to tie those things together, correct?
That's absolutely true, particularly if you sit and think about, many organizations are today hybrid. And hybrid meaning, on-prem, private cloud, public cloud, but also multi-cloud as well. And in that kind of an environment, the network really is a normalizer, right? It's a common denominator across all of those environments because network activity looks similar in all of these environments. And consequently, when you extend observability to use network intelligence, in other words, deep observability, you actually can use techniques and procedures by operators across all of these hybrid cloud infrastructures without having to retrain and redo your entire monitoring stack.
It's funny, somebody just asked me about hybrid versus public cloud and said, do I ever see an era where everything moves? We run everything in public clouds. And I said, maybe, but it's long after I retire. So I'm not sure it's all that relevant. So I know one of the areas that deep observability really helps in is in security, right? In fact, security is getting harder and harder to do. In fact, a CISO I talked to the other day said it's pretty clear that the way security has been approached by companies isn't working, hasn't ever worked, and isn't ever going to work unless we change the way we think about it. So before we talk specifically about, though, how deep observability can actually help with a lot of the kind of newer threats that are around, give me a sense of some of the tactics, techniques, and procedures that bad actors are using today, and how that differs from what we saw before.
Yeah, sure. So TTPs, that's the acronym that's used, right? Tactics, techniques, and procedures are basically patterns of activities or methods associated with specific threat actors or groups of threat actors, right? And they help security professionals in investigating incidents, in triaging incidents, and then responding to those incidents and attacks as well. As an example, threat actors will use techniques like phishing or spear phishing, and there are entire frameworks set up to go do that, to be able to push and exploit certain vulnerabilities so that they can establish presence as a first step on your end systems, on your endpoints. And then once they've established presence, to then escalate privileges. And there are techniques they use to go do that as well. And once they have established presence and they have escalated privileges, then they will use other techniques and procedures to enumerate the infrastructure, to enumerate the drives, and then move laterally over time and spread across the infrastructure. And then to be able to take data and then exfiltrate the data from across all of the different places that they have managed to establish presence on. Now, what is important in the context of observability, particularly when we talk about TTPs, or tactics, techniques, and procedures, is that once bad actors successfully establish presence and can escalate privileges, one of the first things they do is they turn off things like logging at the endpoint, right? And this is really important. We talked about the inside-out approach of traditional observability, which is you're extracting telemetry from the workloads themselves. But if the bad actors manage to establish presence and escalate privileges, and they can turn off endpoint protection or endpoint logging for short periods of time until they do their activities and they turn it back on, this creates gaps in your traditional observability telemetry, right? And this is why traditional observability for security, it doesn't quite do the trick, because it creates gaps in the telemetry data precisely at the points where you need that telemetry, right? And this is why the outside-in approach, the network-based approach, is so critical to be able to augment observability when it comes to security.
Yeah, that's interesting, because the lateral movement, actually, this is something I know you and I have talked about for the better part of a decade, right? These low, slow threats are the ones that really get, they find a way in. They're really not observable, if you will, by traditional security tools, and then they spread laterally without IT really being aware of it, right? I think, or the security team being aware of it. And the problem with those is that they're very hard to find. In fact, my research shows that a breach still takes the better part of a quarter, sometimes up to 4 months to find. And you think about the impact that that can have to an organization, right? That once it's in, it's very difficult to get out. And of course, since the pandemic started, there's been this big rise of ransomware. We've got more entry points for companies. And so if you think you've had a problem with these lateral threats before, I think once we move to this hybrid world, it's just simply going to get worse. So now this outside-in approach you talked about is really, that network-based approach. How does it actually mitigate against these things?
Yeah, so this is important to get our arms around, because there are a few things that network-based approaches bring to the table of observability. The first thing to understand is that anytime there's any command and control activity, any beaconing, it happens over the network, right? Anytime there's any lateral movement of malware, it happens over the network. Any data exfiltration takes place over the network. And so there is always a network footprint, which the key word I will use is there's a network footprint which is in some sense immutable, right? It's there. It's ground zero of the truth if you can catch that network activity, and you can't turn it off because it's happening over the network, right? And so being able to leverage the network data to find those breadcrumbs is absolutely critical. So that's the first piece about how network-based approaches can help mitigate against some of these challenges where traditional observability approaches fall a little bit short. Another important point, and this is really, really important also to understand, is that when you're dealing with things like logs, as an example, that are generated from from endpoints or endpoint protection and other systems, you're dealing with very large volumes of data, many of which are extraneous or irrelevant to what you're really trying to do from a forensics and a triage perspective, right? There's just massive amounts of data in your SIM because there's just so much going on. And what that does is it significantly increases the cost of your security infrastructure, but it increases the time to detection and triage because your queries take longer. You have to sift through massive amounts of data, some of which may not even be relevant to your use case. When you look at network-based approaches, right, you can be very surgical. You can say, okay, I want to analyze all my DNS traffic, and I want to send only my DNS traffic or a couple of other pieces into my SIM. And my queries can be very targeted to be able to find that information in my DNS queries because it's there on the wire, literally, and picking up stuff from the wire as well, right? And so when it comes to dealing with incident response, when it comes to forensics triage, using network-based approaches can result in a much faster time to detection, a much faster time to resolution, and it can help the operator get significant more value out of their SIMs, considering how much they're paying anyway for their SIM infrastructure.
Yeah, and in fact, I want to make sure that the people watching the ZKast fully understand the importance of what you're talking about. The traditional security tools have historically been about finding breaches on that specific device or endpoint, right? So EDR does a great job of finding breaches on an endpoint, right? And you have cloud security detection tools, you have CASB tools and things like that. What they don't have is that end-to-end knowledge to understand how everything got put together. And so it's possible, in fact, it's likely sometimes that with an EDR tool, you find a breach on an endpoint, but that doesn't mean you find the root cause of it. You simply just find the breach because the problem was probably emanated somewhere else. And so I've always said that these detection and response tools, like an EDR, are great at the D, at the detection, but really not very good at the response because they just don't know where these problems came from. And in fact, I feel the same way about SIEMs and tools like that. And if you look at every major breach that we've had, go back a decade or so, some security tool somewhere says we caught the breach, but IT wasn't able to see it properly. And then you have to ask yourself, well, then you didn't, if you couldn't respond to it, you really didn't catch it, right? I mean, it's a pretty simple, if you just give it the eyeball test, it's a pretty simple thing to understand.
It absolutely is. And by the way, it may be simple, but it is one of the places where many, security strategies fall short, right? Which is, by the way, I'm a big believer in frameworks when it comes to security. Security is complex. And in order to make sure you're covering a basis, it's good to follow some frameworks. And there are many good frameworks out there. Pick one. The NIST framework as an example, right? The NIST cybersecurity framework is a good one. It talks about identify, protect, detect, respond, and recover. And there are very explicit controls in every one of these, but there's a reason why it talks about identify, protect, detect, respond, and recover, right? And so they're all integral to a security strategy. And it's not sufficient to simply say, oh, I'm going to put a firewall and an IPS or an IDS and in some sense call it done with some policy controls. That is the protect part, right? But you still have to focus on detect, respond, and recover. And that's where most organizations struggle with, because once you've detected an incident, if you don't have the right telemetry data to do your forensics, to do your triage, you really don't know the extent of the breach or the intent of the breach. And both are equally important.
Yeah, now there's a term thrown around in security all the time that talks about defense in depth, right? And it seems that most security tools help with defense or depth, but not really ever both. So explain how deep observability is actually, the way I think about it anyways, it's kind of the glue that actually brings us together and helps you not only protect better, but actually go much deeper as well.
Yeah, I think it ties into what I was mentioning earlier, right? Which is when you sit and think a little bit about security frameworks, just since I talked about the NIST framework, just as a NIST framework, right? The notion of defense in depth applies at every stage of the NIST framework, right? You start with identifying, you identify your assets, you enumerate your assets, you identify the dependencies between them. Once you understand that, then you can come in and put in the policies to be able to protect those workloads. You can apply a zero trust policies. We talk about zero trust so much today, right? But the foundation of zero trust is really understanding your applications, your workloads, and the dependency between them, and then applying all the policies to be able to control access. But that is not sufficient, right? You have to go to the next step, which is that even with all of this, it is possible that maybe some tokens get compromised, your identity gets compromised, and a bad actor manages to establish presence, and he can move laterally across a framework because he has the privileges to go do that. And now you have to detect his activity, and you have to find the breadcrumbs that can lead to that activity. And that's where the network traffic data really, really helps, having that information out there. And once you've detected that, then you can figure out what your response process is, and then you can do the remediation as well. So this entire framework is a critical aspect of defense in depth. When we sit and talk about zero trust, zero trust access control is important, but you got to go beyond the access control. You have to put in the detection, you have to put in the forensics, the triage. That's all part of defense in depth. And I don't think you can do it without the network-based visibility. That, by the way, in many ways has been used in the traditional data center in the past. In the cloud, it's been slow to pick up, but now we're beginning to see a lot of customers come to us and talk to us a little bit about getting access to some of that network data and tying it into their observability solutions. Yeah,
I'm glad you brought some of those topics up, because it's I think with the role deep observability plays with zero trust is that I've talked to a lot of companies that are investigating zero trust today, and they get stuck because they're not sure how to set up their segmentation policies or their their zero trust policies. And if you're not familiar with zero trust and you're watching this, it's a pretty simple concept to understand, hard to implement, but it's really based on the concept that you don't let any device talk to any device unless explicitly allowed, but you have to have some kind of map that tells you what those normal communications are so you know what to allow to communicate. And so I think from a very high level, it's easy to understand that I don't want guests talking to my accounting servers, right? But once you get even more granular than that there's specific people in the company that you want, or even down to the process level, right? That's where, the concept of, zero trust becomes very difficult. And there's a phrase, right? You can't manage or you can't secure what you can't see. And so I think deep observability lets you see more so you can protect better. And I think that's maybe a good way a fairly simple way to understand it. So
it is. And I think, you're hitting on an important point here, which is that, it's one thing dealing with this in the traditional world, but the cloud world actually brings on its own dimensions of complexity. When we sit and think about cloud architecture and re-architecture of applications, what you have now are monolith applications that are getting completely disintegrated into microservices, right? Using containers and service meshes and so on. And in order to implement zero trust correctly, you have to identify all of the different communications between all of those different microservices, right? And they're all talking to each other using APIs. There's API explosion. So this is a complex problem. And most traditional techniques for identifying all of the different services and the communications relied on, as configured, right? You configure your applications, you configure your services, and then based on that, you apply your policies. But there's a gap between as configured and as discovered, right? And that gap is growing because things change. Nothing's static anymore. Things are pretty dynamic. And so when you analyze a network footprint of these microservices, of all of these different containers, you can actually tell who is really talking to whom. And then you can baseline that and say, okay, are these communications really valid or not? But if you're not looking at that kind of a communication pattern, it's really hard to build out the as discovered map and apply your zero trust policies correctly, right? So we are big believers in applying network-based approaches to zero trust.
Yeah, now let's kind of pivot back to the concept of observability where we started. There's lots of observability vendors. Some are, your alliance partners in some ways, right? And Gigamon, I think it was a deep observability vendor. So are the solutions, are the observability and deep observability worlds, are they complementary, or does deep observability eventually replace observability? How should people that are watching this think about those two product categories?
They very much are complementary. And in fact, that's really the whole premise of defense in depth, right? Which is that you have multiple layers to your strategy, where if you run into challenges or you subvert one layer, the subsequent layers can provide you the information and the protection and the capabilities you need. So observability and deep observability are very much complementary. However, they are not optional, right? And this is important. Just because they're complementary doesn't mean they're optional. They are essential. You need both. And which is why deep observability is really an extension of observability, but to account for the security use cases.
Yeah. And in fact, I think a good maybe to think about it is, the deep observability data that Gigamon provides, it itself isn't, something like a SIM, but you make SIMs better, right? It's not an XDR solution, but it makes XDR better, right? So you're providing more granular data, so the tools that you've already invested in actually can do their job better, and because they're all based on data, and there's it's an important lesson, because I know a lot of people value the role of the network. Is it a commodity? Is it not? But it's the only IT resource that ties the digital world together, right? We're moving things to the cloud. We're moving people mobile. We're moving people to home. And what's that one resource that ties the thing together? Well, it's the network. And so how can you secure without network knowledge?
Yep, so completely agreed. Well said.
Yeah. Anyways, I think we've explored this topic now, and I think it's a great topic, and I think deep observability is something that's kind of sat on the periphery of this world of observability for a while, but I think more and more it becomes important. So Shehzad, as always, thanks for your time. You're one of the smartest guys in the industry that I know. No wonder so it's always a pleasure having you on. If you're watching this, don't forget to click the subscribe, and I'm ZS Caravel, and I'll see you next time on ZKast.